Okay, so let us verify. Okay, so I am recording. So for this lab is entitled Centripetal Force, and obviously you'll find it in the course content area. You should be seeing my screen to the left, and let's see on the bottom here, I gave you an alternate URL in the event that you can't get to it via this handwritten website. So I'll just go to it. It's on the right here, but I'll just verify that it is actually working as of this recording. So you'll go there and you'll click begin, and it should take you to the simulation. All right, so I have it on the right side already, so let me back up a few paces here so that we can read this and work the simulation simultaneously. And so I'm on the left side here. We've already got to the website, and it just basically says that this is a truly classical lab invented decades ago by using common classroom household materials. There's going to be a moving mass, which we'll call M1, and it's going to be varied using the up and down arrows. And there's going to be some hanging mass, M2, and it's going to be varied by clicking the number of washers and changing. In other words, the number of washers is going to be changed. You'll simply click on, let's reset this. You'll simply click on the picture of the washers, and it's going to change. All right. Now, the downside to this is that the simulation is that it's kind of hard to get back to the number of washers if you have to reset this for whatever reason. So let's just say I wanted to mimic what you guys are doing. Let's say you picked 24 washers, and I wanted to get to 24 washers, because the first time around, it's going to ask us to have a moving mass of 25 grams and let's see, 10 washers. So sometimes you have to kind of cycle through this a couple times until you get to 10. I know it's a little painful, but it's just how this simulation was built. I can probably find another one. I haven't been able to find actually a better one than this one that kind of shows this this experiment in the online sense. So let's look at it from the perspective, before we get into the simulation, let's look at it from what it would actually look like if you were doing it inside a real lab. So the sound on this, the sound quality is kind of low, but just watch the video.
Get it spinning over your head. You'll need a friend for data
Okay, so
collection
you'll
here.
see
Your friend is gonna
this
measure
mass
the
spinning
time it takes
around.
to
He
go
has a
around 10
cord of
times.
some
You
length,
can let your friend do the
a
spinning with
rope,
you.
and he
You'll
has
find
a
how long it takes
hanging
to go around 10
mass
times.
there.
That'll let you calculate the velocity.
Okay, so
Letting it
again,
then graph out how does the centripetal force
sound is
affect
pretty
the velocity
poor
of a stopper.
quality, but
To get your
I think you
centripetal
can kind
force,
of see
there's
the
a
picture there.
table in its learning that.
So let's stop that video, and let's take you back to the document as well as the simulation. Okay, so for this first simulation, you're going to begin with 10 washers, and you're going to have a moving mass of 25 grams. So the moving mass, again, you're not going to be able to get to it probably the first time around. You have to kind of cycle through this. All right, so I got lucky there, and I was able to get it at 25 grams, and I wanted the radius to be 200 centimeters. Right, and so play around with this a couple times. Just understand that the variables are not perfect here. And then the second thing you're going to do, I'm in step 4. You're going to figure out the elapsed time in the stopwatch. So what you'll do is, I suggest that you go through 10 revolutions. And so I'm on the right side here. I'm going to hit the start button, and I'm going to count out 10 revolutions. So there's 1, 2, 3, 4, 5, 7, Now, you may have noticed that I didn't go through 10 revolutions. I purposely did that just to kind of give you some insight in terms of why we take multiple readings. So if I were to do this, I probably would document that erroneously, that it took me 15.7 seconds. And so, I would just simply reset this. I'm keeping in mind that, okay, I've already figured out what my moving mass is. It's 25 grams. My hanging mass is, I'll let you think about how many kilograms that is and how many meters the radius is across there. So let's see, I'll reset that. Luckily, this stays as 25 grams, 200 centimeters and 10 washers. So those pieces stay in place. But remember, I erroneously, you may have noticed that I went through 10 revolutions. So this time, let's see. I'll go ahead and start it again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this time it turned out to be about 14.2 seconds. So either, I made a mistake or I didn't stop the stopwatch at the precise moment when that ball was, straight across here. It's kind of hard to get the depth perception from the simulation, but that might give you an indication that something may have went off. Or if you want to save yourself a little bit of time and making sure that all the presets are in the same place, you might say to yourself, well, what if I did 5 revolutions? How much would that differ? So I reset it, I start it. So I'm expecting 1, 2, 3, 4, 5 revolutions to be about half of what 10 was. All right, so that second time that I did it, I have about 14.2. Now the third time with 5 revolutions, I get 7.1, which is telling me that something probably went wrong, and I may need to recalculate and do a couple more cycles to this experiment. So that's kind of reason why we go through multiple experiments. There's always going to be some variables, so you want to make sure you go through that. Okay, so keep in mind for this experiment that you're definitely going to need to convert into SI units, because in the simulation over here, most of these numbers are in SI, non-SI units, as well as, so the number of washers, which you need to think through, the moving mass, which is this piece that's changing here, as well as this meter stick. This 2-meter stick is not in SI units, so you're going to need to think through that. Okay, so now using the calculations, what you're going to need to do is figure out to calculate the weight of the hanging mass, right? And that's weight. There's a difference between weight and mass. Make sure you distinguish that. And then you should be able to do this. Let's see here. Number 2, it says the weight you calculated in the last questions equals to the centripetal force of the moving mass. So if you remember from this experiment here, this guy is moving this mass around in a circle, and it's enough to keep this force or this weight here from falling down.
They tell you
Right?
for example, 200 grams.
So
It's 10
prior
You'll
to,
need a friend for data collection here.
doesn't
Your
show,
over your head. Place a binder clip
prior to
to mark the
the
radius that
piece
you're
is
using.
simply
Really don't
hanging.
let the binder clip
And then
actually
at some point it'll
get it
begin to
spinning over
move
your head.
upward.
You'll need a friend for data collection
Right?
here. Your friend
And
is going
it'll
to
stay
measure the
in that
time it
certain
takes to go
position.
around 10
If
times,
there
or
was
you can
not
let your
enough
friend do the same
force,
and you
this
time how long it
mass
takes to
here
go around 10
that's
times. That'll
hanging
let
will
you
just
calculate the
simply fall
velocity,
down,
letting you
and
then graph
obviously
out how does the
this
centripetal force
would not
affect
rotate.
the velocity of a stopper to
So
get your
again, back to the simulation or the document. So in step number 3, what you need to do is you need to figure out what your experimental value is versus what you figure out in the prior step. They should be roughly, within, plus or minus a few percentage points away from one another. If they're significantly off, then you made a mistake. So repeat the experiment. You may have to change. Well, in this case, you can't. I've set it up so that you're fixed at, let's see, these parameters here, 10 washers, 25 grams moving in a circle, and 200 centimeters. Now, in the second part of this experiment, I say set new values for the hanging mass. So these are values that you are going to select, right? And it should be unique from your classmates. So please make sure if you work with somebody else, make sure that you have the proper, just make sure that you use your own work. I don't have any problem with you guys working in groups, none whatsoever. Go and get whatever resources, what you need, but you have to understand that this is your work. And so if you can't authenticate it for yourself, it's considered plagiarism, okay? And so in a situation, this situation here, you're just gonna go through the same process here, and you're just gonna create your own values, a hanging mass, a moving mass, and your radius, and just kind of repeat this all over again. Right, and then you're going to answer the questions. The last part of this is just simply what you see in this YouTube video, right? And so you don't have to do it. If you want to, you can, just for fun. There's no extra credit whatsoever here, but it does make for a pretty fun experiment. Just be careful. You can easily, hit yourself and do a little bit of damage to your head. So when I did this, and I was using some quarters, just wasn't careful, and I hit myself in the head, and hurts for a little bit, but just be careful. Okay, so I think that should be it for this experiment. Good luck.